The given problem is show that the area of the parallelogram whose diagonal are represented by a vector and b vector given by half of a vector modulus of a vector cross b vector. So first we have to prove this part. In this question we have two parts. This is previously, and then also find the area of the parallelogram whose diagonals are 2 I cap minus j cap plus k cap and I cap plus 3 j cap minus k cap. Actually we know that if two adjacent sides of the parallelogram are given, so I am taking here the diagonal is a, இங்கே diagonal கொடுத்துருக்கிறது a vector, இன்னொரு diagonal வந்து b vector எடுத்துக்கிறோம். So if the diagonals are given, what will be the area of the parallelogram? That is half of a vector cross b, modulus of a vector cross b vector. So the solution, we have taken that the adjacent sides of the parallelogram be the vector c and d. So the adjacent sides I am taking that one is c vector and the other is d vector. In a parallelogram, if this is c vector and this is also going to be c vector, and if this is d vector, this is also going to be d vector. So நமக்கு தெரியும், if adjacent sides கொடுத்துட்டாங்க அப்படின்னா the area of the parallelogram is the magnitude of their cross product. If two adjacent sides are given, then this area of this parallelogram will be c vector cross d vector. Okay, this diagonal is represented by a vector, so that a vector can be written as c vector plus d vector. So this is triangle law of addition. So இது ஒரு triangle. ஸோ இந்த ட்ரையாங்கிள் எடுத்துக்கிட்டோன்னா சி வெக்டாரையும் டி வெக்டாரையும் ஆட் பண்ணால் எனக்கு ஏ வெக்டார் கிடைக்கும். இந்த டைரக்ஷன் சி வெக்டார், அதுக்கப்புறம் டி வெக்டார், ஸோ ஏ வெக்டார். அதே மாதிரி ஸோ திஸ் பி வெக்டார் கேன் பி ரெப்ரசன்டட் ஆஸ் the direction of d vector is opposite that we have taken. நம்ம எடுக்கிற அந்த டைரக்ஷன் டி வெக்டாரோட டைரக்ஷன் இப்படி எடுக்கிறோம், அப்போ தான் அடுத்து சி எடுக்க முடியும். ஸோ அதனால் மைனஸ் டி வெக்டார். ஸோ சி வெக்டாரோட டைரக்ஷன் அப்படியே தான் நம்ம எடுத்துக்கிறோம், ப்ளஸ் சி வெக்டார். ஸோ டி சி இது ரெண்டுத்தையும் ஆட் பண்ணால் பி. ஸோ இப்படி தான் நம்ம டைரக்ஷன் எடுக்கணும். ஸோ டியோட டைரக்ஷன் ஆப்போசிட்டில் இருக்குது, ஸோ தட் ரெப்ரசன்ஸ் மைனஸ். ஸோ இப்போ எனக்கு பி என்னென்னு எழுதுனா b vector is equal to c vector minus d vector. Let this equation be 1 and this equation be 2. Just I am writing a vector is addition of c vector and d vector, and b vector is addition of c vector minus d vector. So that is the both vectors. I have written the diagonals as the sum of the adjacent sides. Okay. So I know that area is c vector cross d vector. If two adjacent sides are given, area is equal to modulus of c vector cross d vector. So from here I can derive the c vector. What is a vector? A vector is equal to c vector plus d vector, and b vector is equal to c vector minus d vector. If you cancel this, plus d vector and minus d vector will be cancelled. So I get this side, it will become 2c vector. If you add this side, it will become a vector plus b vector. So I get c vector, a vector plus b vector equal to 2c vector. So keep c vector there. If this 2 come this side, it will become half of a vector plus b vector. This is going to be my c vector. So parallelly we can find the d vector. What is d vector? D vector, if you substitute somewhere here c vector, the value of c vector here, so we'll get d vector. I am taking the first equation, a vector is equal to c vector plus d vector. 1 implies a vector is equal to c vector plus d vector. I need D vector. So D vector is equal to A vector minus C vector. I'm substituting the value of C vector. A vector minus the value of C vector is 1 by 2 A vector plus B vector equal to D vector. So A vector, if you multiply minus of inside, minus of A vector minus of B vector equal to D vector. A vector minus of A vector, that is going to be half of A vector. This is 1 minus half is going to be half of A vector minus half of B vector. Taking off commonly out, so I get half of A vector minus B vector. This is equal to D vector. So I get C vector is equal to half of A vector plus B vector. Then D vector is equal to half of A vector minus B vector. So I am expressing C and D in the form of A and B. So if the area was modulus of C vector cross D vector, so we have that area is equal to modulus of C vector cross D vector. So modulus of what is C vector? My C vector is going to be half of A vector plus B vector. So half of A vector plus B vector cross the D vector half of A vector minus B vector. So if you cross product it 1 by 2 into 1 by 2, it will become 1 by 4. So the modulus of 1 by 4 will be out. Then inside modulus of A vector cross A vector cross A vector, then A vector into A vector into minus B vector, that is minus A vector cross B vector, and then plus B vector into A vector plus B vector in cross A vector, and then minus B vector cross B vector. Okay, so we know that in cross product, if we have same vectors, if you cross it, it will become 0. We know that I cross I, that is going to be 0, because we have cross product as sine theta, sine 0 as value 0, the same vector as 0 degree, so the value will become 0. So here we have 1 by 4 modulus of A cross A will be 0 minus A vector cross B vector plus B vector cross A vector. Here we have B cross into B cross, that is going to be 0. So we have the remaining terms 1 by 4 minus A vector cross B vector plus B vector cross A vector. So we have the remaining term 1 by 4 into modulus of minus of A vector cross B vector plus B vector cross A vector. So the B vector cross A vector can going to use one rule, that is B vector cross A vector is equal to minus of A vector cross B vector. So applying this rule here, we get 1 by 4 modulus of minus of A vector cross B vector. So B vector cross A vector can be written as minus of A vector cross B vector. So after applying this rule, we have 2 times of minus A vector cross B vector minus A vector cross B vector, so that we have 1 by 4 modulus of minus 2 times of A vector cross B vector. If you take modulus for this, we have 1 by 4 minus of modulus of 2 modulus of A vector cross B vector. Modulus of minus 2 will be 2, 1 by 4 into 2 modulus of A vector cross B vector if you cancel here 1 2s are 2, 2 2s are 4, so that I have 1 by 2 into modulus of A vector cross B vector, which is I get area. So area in the form of diagonals. This is the proof of the first part. The next part is to find the area of the parallelogram. The diagonals are given. A vector is equal to 2 I cap minus j cap plus k cap. B vector is equal to I cap plus 3j cap minus k cap. So the area of the parallelogram, if the diagonals are given, this was the derived formula, just now we have derived it. So we can use the formula to find the area of the parallelogram. For that we have to find the cross product A vector cross B vector. So how to do the cross product is, first we have used the first row by I, j and k, and the second row the A vectors components 2, minus 1 and 1. In the third row we have to use the B vectors components 1, 3, minus 1. Just now we have to do by using the determinant. How we have do is keeping the first row and first column, we have to take determinant for this values. Minus 1, 1, 3, minus 1. So plus, then we have to go with minus j cap into determinant of deleting this row and column. We have 2, 1, 1, minus 1, 2, 1, 1, minus 1. Then plus k into keeping this row and column, we have to go with 2, minus 1, 1, 3. So keeping I cap, taking determinant for this, we know how to take a 2 cross 2 determinant. Minus 1 into 1, it is 1, minus 3 ones are 3, minus j cap into 2 ones are minus 2, minus 1 ones are 1, plus k cap into 2 3s are 6, minus 1 into minus 1, it is going to be plus 1. This is the way we have to take a determinant for every 3 cross 3 matrix, so that we have using here also. Next we have to go to finding the determinant value of this. So I cap into 1 minus 3, that is minus 2, and then minus 1 minus 2 minus 1, that is minus 3, minus 3 into minus, that is plus 3j. Here 6 plus 1, we have 7 k cap. This is A vector cross B vector. To find the area, we have to go to the modulus value of this vector, so that we can find the area. So area is equal to half of modulus of A vector cross B vector. First we have to find the modulus of this vector. To find the modulus, we know how to find a modulus for a vector. We have given that A vector cross B vector equal to minus 2 I cap plus 3 j cap plus 7 k cap. So how to take modulus for this vector, modulus of A vector cross B vector? Simply we have to take root and square all the coefficients. So minus 2 square plus 3 square plus 7 square. So root of, if you square the minus 2, it will become 4. 3 square, it is 9. 7 square, it is 14. So the value 49. Seven square, it is 49. That is the value of this. If you sum this, it will become root of 62. So actually area is equal to half of modulus of A vector cross B vector. That is, modulus of A vector cross B vector is root 62. So root 62 by 2 square units. this is the solution for this problem. In the first, we have proved that the area of the parallelogram, if the diagonals are given, so that I am taking the adjacent side C and D, replace A by C vector plus D vector, and replace B by C vector minus D vector, and I am writing C vector in the term of A and B, and D vector in the terms of A and B. So here we have written C vector in the form of A and B and D vector in the form of A minus B by using the normal elimination methods and the substitution methods. And then I have find out the area by using area formula C vector cross D vector. So at last we have used the derived formula. At last we have used the derived formula. We have derived the formula, that is area is equal to half of A vector plus B vector, and applying that in the second part, they are given a diagonals. Then we have applied it and find the area for the given diagonal as vectors. Thank you.